Hello and welcome to Zig's Math Lessons. I'm your host, Ziggleby Stunk. This channel is only for the best science, technology, engineering, and mathematics students. I'd recommend that you watch these videos with pencil and notebook handy and maintain the policy that if it's in the video, then it goes in your notes. In addition to that, any serious math student must memorize their times tables until they know them as a reflex. Now let's begin. Today we are going to consider the domains and ranges of relations. We'll start by stating the domain and the range of some graphs. To do this, we need to get used to a whole lot of new notation. So let's look at this graph. This is an ellipse put on the XY grid. And to state it, we'll start with domain. We need to get used to a lot of new notation. So we could say that the domain is the set of x in real numbers. This is what all these little symbols mean. The domain is the set, because that's a set bracket, of x. Here's a new symbol. It means is in. So x is in, and R stands for real numbers. X is in real numbers. That's what this notation says, and you just have to get used to it. It's easy. Once you're used to it, it's really very simple. Now, we say x is in real numbers because we can see that x, the possible x values along this ellipse, go through all the real numbers. It's not just 1 or 2 or 3, but it's also 2.5 is there, and 2.7 and 2.721, all the decimals, all the real numbers. So whenever there's a continuous line of a graph, what we do is we say that x is in real numbers. The only time we don't is when what we're looking at is several points or a piece or pieces of a graph. But this is one continuous line, so we say x is in real numbers, and this vertical line is read as such that. So this is the domain is the set of x is in real numbers such that, and the lowest x we see is -3, while the highest x we see is 6. So we put x in between 3 and 6. And that's what you would say in conversation. Where's x? It's in between -3 and 6. And so there it is. X is in between -3 and 6. And these signs have to be less than or equal to signs, like this. So here we have the statement of the domain. Domain is the set of x is in real numbers such that -3 is less than or equal to x, which in turn is less than or equal to 6. That's the domain. The range, we do the same thing with the y value. So we see that the lowest y value is -2, while the highest y value is 4. And so we say the range is the set of y is in real numbers such that. That's what all these symbols mean. You just have to get used to it, and it's really pretty simple. Y is in real numbers such that, and in conversation we'd say y is in between -2 and 4. So we actually put y in between -2 and 4. And we use less than or equal to symbols like this. This symbol says less than or equal to. Notice, please, the lowest number out of these two, -2 and 4, the lowest number goes on the left. See -3 and 6, the lowest number goes on the left. Another way to say this, well, there's another notation, and it's called interval notation. We could say that x is in the interval between -3 and 6. And we can say that y is in the interval between -2 and 4. It's more notation. That's an is in symbol. This is interval notation. Let's take a look at this. In conversation, we would say, okay, well, let's look at the domain. It could be x seems to start at 2 here and goes to the right. So x is greater than 2. In conversation, that would be fine. But now we just translate that into math symbols. The domain is the set of x is in real numbers such that. That's what these symbols mean. The domain is the set of x is in real numbers such that. And now in conversation, x is bigger than, x is just all these numbers along this blue line, which is all the x numbers that are bigger than 2. So we could say x is greater than or equal to 2. While for range, we can say that range is the set of y is in real numbers such that. That's what all those symbols mean. And then in conversation, we can see that y starts at 0 on the y-axis here. Y starts at 0 and goes up and up and up and up. So y is greater than or equal to 0. In interval notation, x is in the interval between 2 and infinity, while y is in the interval between 0 and infinity. Here's another function on a grid. And we notice that it seems to be in pieces. Here's a piece, here's a piece, here's a piece. So we call this type of function a piecewise function because it's in pieces. And so once again, we see that because this is a continual line and not a series of points. If it was a series of points, the story would be different. But it's a continuous line along here. So we say that x is in real numbers. And here we go. The domain is the set of x is in real numbers such that, now let's consider this. If we were just talking it over, we would say that it seems to start at -8 and go and go and go all the way up to -2 as far as the x value is concerned, -2. And then there's this open dot, which means that point is excluded. So we're missing a -2 on our x, or our domain. But that -2 is immediately picked up here. It's like a handoff in football. The ball is handed off to this piece that picks it up exactly at -2 and continues with it all the way up to x equals 2. And then the next piece immediately picks up exactly where this part left off and continues with x values all the way up to the number 9. So there's no breaks between -8 and +9. So we say that the domain is the set of x is in real numbers such that x is in between -8 and 9. So we put x in between -8 and 9 with the lowest number on the left and less than or equal to signs. And this symbol here, less than with the half equal sign, means less than or equal to. And that's because this dot is closed on the end at -8, which means we're going to include -8 in our solution. But we see that the dot on the 9 for an x value is open, which means that we must exclude that. But we won't accept an x value of 9 because there's clearly a gap there. So we have to exclude 9, and that's how you do it. We must say that x is less than 9, not equal to. In interval notation, to exclude the 9, we use a round bracket like this. X is in the interval between -8 and 9. And now the round bracket here means exclude the 9 from the interval. So that's how we say less than, using interval notation when there's a gap there. And now to consider the range. The range is the set of y's in real numbers such that, and now we have to list all the pieces. We can see that y could equal -2. All along here, y equals -2. Or y is in between 0, this is 0 on the y-axis, between 0 and 2. Or y is equal to 4, because all along here, y equals 4. So we can make a list. The range is the set of y is in R such that y equals -2, comma, between 0 and 2, all along here, y is in between 0 and 2, so we've got y literally in between 0 and 2 with less than or equal to signs, including the endpoints because this is less than or equal to. So we'll include these because those are closed dots. And or y equals 4. Y equals 4 all along there, y equals 4. So it's kind of a list. -2, or in between 0 and 2, or 4. So we have to make that list. State the domain and range of a function, and we look at this, it looks like a grade 10 parabola. Solution. Sometimes the easiest approach is to make a sketch and then use that sketch to state the domain and range. Now we know from grade 10 that this is a parabola that opens down from the vertex 2, 3. It opens down because the square is negative. And the vertex is change the sign in here, leave the sign there, so the vertex is 2, 3. So we can make a rough sketch of that, of a parabola that opens down from the point 2, 3. Here it is. Here's the point 2, 3. Here's the parabola that opens down. And then just in conversation say, well, okay, what's the domain? Well, the domain is the set of x's in reals because of the fact that there's no gaps, there's no asymptotes, there's no holes in this graph, but it's got arrows on the end, which means it goes forever in both directions without a gap. So we can very simply state the domain is x is any real number. While the range, if we were having a conversation with a partner, we might say, it looks like y, the highest y value we see is 3 here, and from there it goes down. It never gets above 3. It comes up to 3, then it turns back. So the range is the set of y is in real numbers such that y is less than or equal to 3. That's stating the domain and range of something like this. Note, for all parabolas that open up or down, if there's arrows on the end, the domain is x's in real numbers. For the range, we could use interval notation and say that y is in the interval between -infinity and 3, because y is less than or equal to 3, so there's this big gap that goes from -infinity all the way up to 3. Now, the square bracket means include 3. The round bracket means we would exclude a number if there was a number here. But since infinity is not a number, we can't include that. So we put a round bracket there. Example, state the domain and range of this function. And it looks like a fraction -2. Okay. Solution, the presence of x in the denominator of a fraction. There's x in the denominator of a fraction. The presence of x in the denominator of a fraction must act as a red flag for the math person. In other words, look out, you're going to have to think about this. You're going to have to look after this fraction because x is in the denominator. Division by 0 is undefined. 5 divided by 0 doesn't make any sense. It's like saying, how many times does 0 go into 5? It doesn't make any sense. So the denominator of a fraction must not be 0. Many people really aren't clear on the fact that fractions are really division questions. Consider a division sign. It looks like this. It represents a fraction. Numerator and denominator. And this part of it can't be 0 because we can't divide by 0. So fractions are division questions and you can't divide by 0. So denominators of fractions can't be 0. So up here in this case, x could be anything but the one number that makes this denominator 0, which is 3. So x is in real numbers such that x is not 3. Now there's also a concern with the range as well, because 5 divided by anything is not 0. 5 divided by 100, for example, is 5 100ths. That's very small, but not 0. 5 divided by 1,000,000 is 5 millionths. And that too is very small, but it's not 0. So this fraction can never be 0. So y can't be 0 minus 2. So y can't be minus 2. The range is the set of y's in real numbers such that y is not minus 2 because of this. Next, state the domain of the function, just the domain this time. We'll leave the range for calculus class. Solution: the presence of x in the denominator of a fraction must act as a red flag for the math person, because no factor of a denominator of a fraction can equal 0. No factor in here could be 0, because then it would be 0 times something. And, well, that would be 0. So no factor can be 0. So our solution is to factor it. And here we are factoring a quadratic expression, just like grade 10, two numbers that multiply to 12 that subtract a 1, or 4 times 3, and we'll take minus 4 and plus 3 because we want minus 1. And we can see that x cannot be 4 because that would make that factor 0, and x cannot be negative 3 because that would make that factor 0. So we can say this: x is not 4 and x is not minus 3. So this required some factoring and some understanding that if x is in the denominator, no factor in the denominator can equal 0. State the domain and range of a function that involves a radical. A radical is a root sign. It's not a revolutionary person in this context. A radical is a root sign. Okay, solution. The presence of the radical or square root sign must act as a red flag for the math person, because radicands, now a radicand, there's a word maybe outside your vocabulary. It means the contents of the radical. It means 3x minus 6 in this case. Radicands must be non-negative, and non-negative means greater than or equal to 0. So our approach is to recognize the red flag, and the red flag means we're going to have to look after the situation of the radical here. And the radicand must be non-negative, so 3x minus 6 must be greater than or equal to 0. So we say it. Then we treat that like an equation. Move the 6 over, divide by 3, and we have x is greater than or equal to 2. So we can state our domain. It's the set of x's in real numbers such that x is greater than or equal to 2. Now there's a little trick with the range as well, because radicals are non-negative. Consider y equals 5 minus root 3x minus 6. That root sign is non-negative, which is pretty much the same as positive. So this is 5 minus something, so it's going down from 5. So y must be less than or equal to 5. Because it's 5 minus something that's positive. So we're going down from 5. And so if y is less than or equal to 5, we can state our range is the set of y's in real numbers such that y is less than or equal to 5. Let's do this again with another example of a function that has a radical in it. Example, state the domain and range of the function. Solution: the presence of the radical or the square root sign must act as a red flag. In other words, you're going to have to think about the fact that there's a radical here. That's the issue. Radicands must be non-negative. So our approach is to set the radicand, the contents of the radical, the 10 minus 2x, and set it greater than or equal to 0. Now this is a greater than or equal to sign. Then we have to treat it like an equation, drag the 10 across. Now I'm going to invite you into the rough area for a moment. In the rough area, consider something completely different than this example. 21 is less than 30. This is a true statement. But if I multiply both sides by negative 1 and change the signs to negatives, negative 20 is less than negative 30. This is a false statement. Negative 21 less than negative 30, this is false. So to make it true, the inequality has to reverse. This less than sign has to become a greater than sign. So moral of the story, when you change the signs across an inequality like I did here, you have to reverse the inequality sign. So here I am over here. I'm going to change the signs across the inequality. This -2 will become positive. This -10 will become positive. But that inequality has to flip over for the reason discussed in the rough area. Divide by 2, and x has to be less than or equal to 5, and that is our domain. Domain is the set of x's in real numbers such that x is less than or equal to 5. Now, once again, this radical is pretty much a positive number. So it's 5 times something positive. So a positive quantity plus 3. Y is equal to a positive quantity plus 3. So y must be greater than or equal to 3, because it's a positive value plus 3. Greater than or equal to 3. The range is the set of y's in R such that y is greater than or equal to 3. And finally, kind of a word problem. At a certain workplace, employees are paid an annual salary, that means per year, an annual salary of $45,000 plus $3,000 for each whole year they've worked there. Express the annual salary S as a function of number of years worked, N, and then state the domain and range. Solution. Well, it says express the annual salary S as a function of the number of years worked N. So we want S of N. We want a function machine into which we can substitute N. And it says the salary is $45,000 plus something. So we can start with that. The S of N is $45,000 plus something. And then it says $3,000 for each whole year worked. Well, it says the number of years worked is N, so it must be $3,000 for every N. And there it is. S of N equals 45,000 plus 3,000 N. The domain, the set of possible N values. Now, N is playing the role of X here. So the domain is the set of possible N values. And you can't work forever, so I had the employee stop working at 20 years. The domain is the set of N, such that N equals 0, 1, 2, up to 20. While the range is the Y values, but Y is S of N. It kind of reminds you of f of x, which we know to be Y. So the range is the set of S of N. It's the set of S of N such that S of N is 45,000, if N is 0, 48,000, 51,000, and so on up to when N equals 20. Plug it in there, and we have the top of our range. I'm not Ziggleby Bieshtuk, but thanks for watching. If you liked it, leave a like. If you like the content, please subscribe.